Okay, so just to refresh our memories, a Bronsted Lowry, this is what I'm going to call it, Bronsted Lowry acid does what with the hydrogen ion?
Takes it. Or no, gives it.
Gives it. It gives away a hydrogen ion, while a Bronsted Lowry base
Takes.
okay, receives it. So let's look at some stuff here. This is a Bronsted Lowry acid or base?
Acid.
Acid, because when it breaks apart like that, correct? And there's the hydrogen ion that it gives. Okay. Sodium hydroxide, when it's in water, breaks apart like it is a Bronsted Lowry
Base.
base. Okay, please look at your polyatomic ion sheet and look for the ammonium ion.
I don't have one.
Find it? What is the ammonium ion? NH4 plus. I will tell you that on the other side of the arrow, ammonia becomes the ammonium ion. Do you think that ammonia is a Bronsted Lowry acid or base?
Base.
It's definitely a base. It received a hydrogen ion. Okay, what about this? First of all, what is this? What is this?
Water.
It is water. Is water. All right. Is water a Bronsted Lowry acid or base? Nope. It has a pH that is neutral. But I would like to know if it is an acid or a base. Acid. So it can give a hydrogen ion. That's true. But isn't it a base as well? Couldn't it accept a hydrogen ion? That is true. Water can act as a Bronsted Lowry acid or a Bronsted Lowry base. It has a big word for that. It's called amphoteric. I'm sure you don't need to know that. Okay, moving on. What you do need to be able to do is look at an equation and determine what is the acid, what is the base. Now, I need you to write this down and then we'll talk. All done? So here's something that you need to know. The acid and the base in a Bronsted-Lowry equation are always reactants. The conjugate base and the conjugate acid are always products. If the acid in the reactants, becomes the conjugate base in the products, what's left over? What's left over becomes the opposite. So if it's the base in the reactants, it's the acid in the products. And remember, an acid donates a hydrogen ion, and a base accepts a hydrogen ion. So conjugate means leftover for you, and you always put the opposite than what happened in the reactants. So the first thing you're going to have to do is identify what's the acid and what's the base in the reactants, and then the products name the leftover opposite. Here we go. So we're going to label the acid, the base, the conjugate acid and the conjugate base. We know the acid and the base need to be what side of the equation? Left. And we know that the conjugate acid and the conjugate base are going to be on the right side. So I'm looking here at the left side, and I need to know what is the acid. What is the definition of a Bronsted-Lowry acid? Right. The acid donates a hydrogen ion. Of these two things, which one can donate a hydrogen ion? H2O. So it has to be the acid. These things must happen in pairs. We do know that the base is anything that's capable of receiving a hydrogen ion. Could we put H plus attached to that? Will it fit? Yeah. So this must be the base. Now on the opposite side of the arrow, what happened to water? It lost a proton. Would it look like this if it lost a proton? Indeed it would. So this would be the conjugate base. This gained a hydrogen ion. Do we see that happening? Yep. So this is the conjugate acid. In the second example, they tell you the acid and the base. And you have to figure out what the products are on the other side. Just as a refresher and a reminder, what does this need to do, gain or lose a proton, a hydrogen ion? It needs to lose a hydrogen ion, while this needs to gain a hydrogen ion. So we want to make sure on the opposite side we make HCl lose a hydrogen ion. Will it be in this spot, the conjugate acid, or in this spot, the conjugate base?
Conjugate base.
Conjugate base. When HCl loses a hydrogen ion, what's left over? Is that correct? Is that correct? -1, very nice. Okay, so what is the conjugate base of HCl? Cl minus. All right, we got that. We made it lose, and we got our conjugate base. Now, we need NH3 to add the hydrogen ion. When you add it, what does that become? NH4 plus. And that is the conjugate acid. Okay, let's try one on your own. Write this one down. Why am I writing HOH that way? Because it's really easy to see it break apart. And when we're talking about acids and bases, that is a good skill. Please finish this equation, identify the acid and base, and write the products and identify the conjugate acid and the conjugate base. Raise your hand when you are DONing. So far, everyone has done this very perfectly. The first step is to identify which one of these is going to be the acid. You chose H2O. So on the other side of this, you need it to gain or lose a proton. Okay, that's it, losing, so it becomes the conjugate base. And then, since this has to be in pairs, NH3 must be the
Base.
and we need to show it gaining the proton or the hydrogen ion, and there we go. I did tell you yesterday that there are two words that describe this. We call it the hydrogen ion, and we also call it a proton. Just to irritate new learners. Sorry about that. Okay. Before you write this down, can you define a binary acid? Made of just two elements. Tell me what monoprotic means.
One hydrogen.
It has one hydrogen. All right. Okay, ladies and gentlemen, here are the directions. For binary atoms, those are the ones that have an H and then some other element that is always a nonmetal. You use a prefix hydro, and that tells you the hydrogen is there. Then you use the root word of the second element, add the suffix ic, an acid. So HCl is hydrochloric acid. HBr is hydrobromic acid. H2S is hydrosulfic acid. Very nice. Hydrosulfic acid. H3P is
Hydrophosphoric acid.
hydrophosphoric acid. I wish we could just end here because you get this, don't you?
Yes.
Please tell me which one of these is a polyprotic acid of these three. Name them. This one is called hydrosulfic. It is polyprotic because it has greater
Two
than
hydrogens.
1 H's. And this is called hydrophosphoric, and it is polyprotic because it has greater than 1. All right, that was easy, wasn't it?
Yeah.
Okay. If it's not a binary acid, what kind is that?
Tertiary.
Ternary, yep.
Oh,
Ternary.
ter-
And here we come.
tertiary.
You know what tertiary comes from the same thing.
Yes.
Okay. A ternary acid is an acid that has a polyatomic ion. Write this down and we will continue on. So write the root word of the polyatomic ion. If the polyatomic ends in ATE, replace the suffix with IC. Here is a polyatomic ion. Find it on your green sheet of happiness and tell me what the root word would be. First of all, what is a polyatomic ion called? Sulfate. What are you going to change it to? Sulfic. Oh, pretend that's spelled right. Sulfic. And actually, they call it sulfuric. Not quite sure why they do that to you. Sulfuric. But the 8 has been changed to ic. Please find chlorate. Its formula is ClO3 minus 1. It is called chlorate. So the name, you would change the ic to chloric. Get how this works? Now, if the polyatomic ion ends in ITE, you replace the suffix with OUS. This is called look at your sheet. Nitrite. The ITE is replaced and becomes nitrous. All right, let us try one more. No, let us not. Here is your memory hook. She ate the poison and it was icky. That reminds you, 8 goes to ick. Take a bite, the cake was delicious. This reminds you that ITE goes to OUS. In this naming scheme, what's missing? Don't you see that you saw on the other side? No hydro on your notes, right? No hydro. with ternary. Here's how I would like you to remember this. I'm going to go back a slide. Oops, not that way. Oh, I forgot I can't go backwards from here. I have to use my computer. Does anybody have a Volt car? A Chevy, no, a Volt, V-O-L-T.
Chevy Volt.
A Chevy Volt or a Chevy Leaf? Do you know what those cars are?
Yes,
What are they?
they are fully electric.
They are fully electric. If they're not fully electric, what do we call that?
Hybrid.
Hybrids. Hybrids. Okay, the car that can go on gas or electricity is a hybrid. So your memory hook is binary acids have hydro. Got it? Did you know this memory hook was happening? Did you feel it coming? Hybrid binary acids need hydro. Write that down and the memory hook. Moving on. Let's name some bases. Write the name of the metal and the Roman numeral that's needed, if needed. When don't you need a Roman numeral?
What is
Yep, when it is group 1 or group 2 or those exceptions. What did we call them? ASCA. Silver, zinc, cadmium, and aluminum. Because these have defined oxidation numbers. So write the name of the metal and a Roman numeral if needed. Add hydroxide to the end. What is the formula for hydroxide? There you go. So sodium hydroxide is, how did we know this is iron 2? Yep, we uncrisscrossed. The name of this base is
Nickel 3.
nickel 3 hydroxide. The name of this base is aluminum hydroxide. Good. All right, you usually do pretty well on these. It's going the other way that drives you nuts. And unfortunately, you have to be driven nuts, writing formulas for acids and bases. Okay, let's see what we can do here. The formula for sulfuric acid. First of all, is this a binary or ternary? Ternary, and you knew it was ternary because no hydro. So you should be looking on your green sheet of happiness for polyatomic ion. Found it?
Yeah.
What's the formula for your polyatomic ion?
SO negative, or 4 negative 2.
SO4 negative 2. All right, it is the anion in this. So the first part of this is going to be what? What do acids start with? H plus. So we're going to crisscross this, and to properly write the formula, it would be H2SO4. With me there? Okay, let's do a harder one. Please write the formula for chlorous acid, chlorous acid, and the formula for hydroiodic acid. So far for the chlorous acid, I've looked at 6 formulas and I'm only seeing one that was right. 2. Still 2. Three. Three. That H, I don't know what that is, otherwise should be right. 4. Yep, 5. 5.
Did you get it right?
6. Not bad. Okay, let us break these apart and see where our problem is. Okay, chlorous acid, binary or ternary? Ternary, because there's no hydro. Now, it ends in OUS. So what does the polyatomic ion end in?
ICE.
ITE. So we're
Oh.
looking for chlorite. And the formula for chlorite is ClO2 minus. What does every acid have to have first?
Hydro.
A proton. And so when I crisscross, I have HClO2. Yes?
Yes.
Okay. Now, this one, binary or ternary?
Binary.
Hybrid, so it has a hybrid. So it has as its ending what? What root is this?
Iodine.
Iodine, right. You took out the IDE. What happened there? Iodine. Okay, and you change it to ic. So this is going to be I. What is the oxidation number of iodine? It's in group 17. It has 7 valence electrons. How many does it want?
1.
Just one more, please. And it's happy when it has gained 1 electron, which makes its charge -1. The hydrogen ion still has a charge of So crisscross applesauce becomes, are we done?
Uh-huh.
No,
No.
not done. Let's try a few more. All right. Please write the formula for these.
Oh, there's gonna be more than one. There's no hydrogen, so it's pterodactyl.
And write the formula for, oh, do. Raise your hand when you think you are correct. And you are. So are you?